Alright, so this is University of California, Santa Cruz, People's Physics textbook number 16, part D. Initial position is 20 meters, initial velocity is 12 meters per second, and the acceleration is free fall acceleration, negative 9.8 meters per second squared. We found the impact velocity, we found the time to get down to the origin, we found the maximum altitude at the apex, and now part D asks for the amount of distance in between the helicopter and the falling object, the falling person, 3 seconds after release. So, firstly we need to find where the person is 3 seconds after release. We're going to use fancy equation number 1, that is displacement equals 1/2 multiplied by acceleration multiplied by time squared plus the initial velocity multiplied by the elapsed time. We expand the displacement term to be the final position minus the initial position because our initial position is 20 meters. Substitute in the acceleration, elapsed time, initial velocity, and grind through the math, and we are 8 meters below our initial position, but our initial position was 20 meters. So the person in free fall is 12 meters above the ground 3 seconds after release. Except that's not what they're asking for. They're asking for the separation between the helicopter and the person. So let's find where the helicopter is 3 seconds after release. It's moving at a constant velocity, 12 meters per second upwards. So it's basically just speed equals distance over time. Average velocity equals displacement divided by elapsed time. We're going to multiply both sides by elapsed time. And then we add the initial position to both sides in order to isolate the final position. So 12 meters per second multiplied by 3 seconds added to the initial position of 20 meters. So the helicopter is 56 meters above the ground. So if the helicopter is 56 meters above the ground and the person is 12 meters above the ground, the difference between the helicopter and the person is 44 meters. That is University of California at Santa Cruz, People's Physics textbook, number 16, chapter 3, part D.